Welcome back to more information about circles. Last time we took notes on page 55. This is a review of that information. So if you didn't get your notes on page 55, you can pause the video here and copy down some of this information. One thing I did not cover with you last time is the formal way we use notation to indicate something like a chord. Since a chord is a line segment, we put a straight line segment above the letters that are the endpoints of the chord. And the endpoints are points on the circle. Remember, a diameter is a chord. It's the longest chord in a circle. Secant, though, is a line. So when we put the letters for a secant, we put little tiny arrowheads at the tips of them. And remember that when we name a circle, we usually use the capital letter that's the center, and we draw a circle with a little dot right in front of it to indicate we're naming a circle. Now, these notes you should be taking on page 56, and we'll call these notes about arcs and angles. So within a circle, you're going to have different size arcs. If the arc is like the red ones you see in these three examples, it's less than 180 degrees. If it's more than 180 degrees, if it's more than half the circle, then we say it's a major arc. When you have an angle, like this one on the far right, that is an inscribed angle, that means the vertex of the angle is on the circle. And we say that this angle, CAB, cuts the minor arc CB. This central angle is an angle whose vertex is at the center. It cuts the same arc. And we could also say that the chord connecting C and B cuts that same arc. So we talk about the measure of arcs by looking at their central angle. So if I have an arc RP, its measure, and we can put a little m in front of it, is the same as the central angle that cuts it. Go ahead and pause if you want to read this slide. So in this diagram, angle 1, sometimes we name an angle with a number on the interior of it. Angle 1 is a central angle. Looks like its vertex is at the center. CD, the two letters with the arc drawn over it, is a minor arc. But CED, named with three letters and an arc over the letters, is the major arc, going from C the long way around the circle past E until it reaches D. So CED is a major arc, CD is a minor arc. This is a typical delta math question. If I have a circle H, that means the center is H, with the measure of an angle GHJ, so G to H to J. Remember, when we name an angle with three letters, the middle letter is the vertex. If that central angle is 68 degrees, then the measure of the minor arc GJ, right here, is still going to be 68. The central angle and the measure of the arc are the same. Using that logic, you can answer this question. The circle is K, so that's the center. Arc JL we're given is 104. So the measure of angle JKL is also going to be 104. Now, we're going to be drawing circles so they just touch all of the sides of a triangle like you see in this picture, and we'll draw them the other way around where the triangle is inside the circle and the corners of the circle or corners of the triangle will be on the circle. So there's going to be different language you need to understand. If the triangle's around the outside of the circle, we say it is circumscribed about the circle. If the circle is inside the triangle, as we have both of these are the same case, we say the circle is inscribed in the triangle, or the triangle is circumscribed about the circle. Notice both of these words have scribed or scribe in it. Scribare in Latin means to write. So that's the root of the word scribe, a person that writes for you if you are illiterate, or the word scribble, or the Spanish word escritorio. All of those are related to writing. So this is drawing around. The triangle is circumscribed around the circle versus the circle inscribed in the triangle. Now, when you have angles that are inscribed, or triangles or quadrilaterals that are inscribed, there's a lot of questions I can ask you. Angle C, or we would call it angle ABC if we named it with 3 letters, it's inscribed. So that means C, the vertex, is on the circle. It intercepts this arc AB, and notice that's written with an arc over the top. I sometimes say it cuts arc AB. If a polygon is inscribed, so this triangle is inscribed inside the circle, or the circle is circumscribed around the triangle, you know that the angles of the triangle are going to add up to 180, and we know that the arcs of the circle are going to add up to 360. So there's a relationship that tells you that basically this inscribed angle is half of the arc it cuts. In this diagram over here, I have angle A with the vertex at A, cuts this major arc here, all the way from B through C to D. So we would write that with 3 letters, BCD, and we would put a little arc over it like we see in this problem. Which angle cuts DAB? DAB is cut by angle C, or angle C intercepts arc DAB. This quadrilateral is inscribed inside the circle, and we say that the circle is circumscribed about the quadrilateral. Turns out, if you look closely, whenever I have a major arc cut by an angle, that angle is obtuse. Versus up here where it's a minor arc, an arc that's less than half the circle, this one up here at AB, it's cut or intercepted by an acute angle. Now it's time to find your textbook. Go ahead and pause the video till you find it. And once you found it, I want you to bookmark these pages. So page 571 has more vocabulary about major and minor arc and semicircle. You're going to want to read that page. Page 576 talks about central angles and inscribed angles and arc length and arc measure, which we will talk about more next week. Page 582 has a very important theorem. An inscribed angle is half the arc it cuts. And we're going to write that down in your notes in a moment. You really want to read through pages 568 and 569 because this is a classical math problem that everybody that's ever learned geometry has encountered. It's about how a guy named Eratosthenes figured out the size of the planet way, way long time ago. Long, long, long before Columbus ever set sail. We may not get to the information on intersecting chords, but those of you that are hoping to go to honors next year should definitely read page 587. Now, this page is not your textbook. It's got colored, printed, bold words. But if you want a quick review of central angle and some key vocabulary, pause the video and read this. Anytime you read a textbook, you'll notice that there are important vocabulary words are in bold. In our textbook, sometimes those words that are in bold are inside of questions. So let's practice a little bit of what we've learned so far. Here are some terms with their notation, and here's their names, what descriptions we have for them. So what would AB represent? AB is a radius. What would CD represent? CD is a chord. What would AD represent with this little symbol on top of it, curved? AD is an arc, and it's exactly half of the circle, so we call it a semicircle. Angle CDA, remember with D in the middle, that's the vertex. The vertex is on the circle, so that's an inscribed angle. How about just the 2 letters AC with a little arcing thing on top? AC is a minor arc. And how about an angle with the letter B in the middle of the three letters? Since B is the center, that is a central angle. Please write this down in your notes. It's a very important theorem. The measure of an inscribed angle is half the measure of the arc that it cuts. And the flip is also true, that the arc is going to be 2 times the measure of the inscribed angle, or twice as big. So in this case, this is an inscribed angle. If it's half the arc it cuts, how big is angle A? Angle A would be 58 degrees because it's half of 116. How about this angle A? Well, the arc that's cutting it is 90 degrees, and that's the angle that's cutting it is half of that arc, and the angle's 90, so this would have to be twice 90 or 180. That means it would be half the circle, and you can kind of see that if you go from this point through the center, straight over to that point, you would have a diameter. Now here I have 3 questions in one diagram. Go ahead and try to figure out what would angle A be, especially assuming that this line here is a diameter. Well, if this arc is a semicircle, it's 180 degrees. So to find A, you would take 180 and take away the 95 to see what's left for the part that's A. And that would tell you that arc A is 85 degrees. How about B? B is inscribed across from an arc that's 95 degrees. So it would be half the arc it cuts. On your calculator, if you do 95 divided by 2, you get 47.5. And lastly, how big is angle C? It's across from this arc, which is half the circle. Angle C would be 90 degrees. And it turns out that all angles inscribed in a semicircle will be 90 degrees because they're half of 180. Pause the video and write these down in your notes. So 2 angles that are inscribed and they both intercept the same arc would have to be congruent because those angles would both be half of the arc. An angle inscribed in a semicircle would be exactly half of 180, so it would have to be a right angle. And if you have opposite angles in a quadrilateral that's inscribed in the circle, those opposite angles each cut a different part of the circle, but together they make the whole circle. So those opposite angles would be supplementary. I'll draw a diagram for you another time and we'll prove that. This is another question from Delta Math, similar to what you'll have for homework. In this case, I'm given a circle J, that's the center, and an angle HLK. HLK. They tell me that the angle is 30 degrees. That means the angle with vertex at L, this angle right where my mouse is 30 degrees. So what's the measure of the arc? Well, the angle is half the arc, so the arc would have to be double the angle. So the arc would have to be 60. How about this one? Again, I'm given an inscribed angle. I'm told it's 23 degrees. What's the measure of the arc? It would be 46 degrees. How about one more? Here's my inscribed angle. It's an acute angle that's 17 degrees. What would be the measure of the arc that it cuts? Inscribed angle is half the arc it cuts. 17 is half of 34. What if I tell you the arc? In this case, you've been told that the arc is 120 degrees. Find the inscribed angle. So the inscribed angle that cuts it with the vertex at R would be half of that arc. Well, what's half of 120? 60. So this Sunday is Pi Day. I hope you have a good time. I hope you get the opportunity to eat some pie. The next time we have a lesson, we're going to be talking more about tangents. We did talk about them a little bit before, but we'll talk about them in a lot more numerical detail.